Going to go over the binomial theorem expansion, partly because you need to learn that, and then partly because it's good practice of your exponent rules. So I've got 3x plus 1 over y squared, and that's all raised to the exponent 5. Now, if you've done this a few times, you'll be able to do this directly, but I'm going to show you a way of doing this indirectly. We'll make a substitution to apply the binomial theorem on a simpler question, and then we'll substitute back and use exponent rules to finish up. So the substitution we're going to make is simple. We will say a takes the place of 3x, and b is going to take the place of 1 over y squared. So I can now say that a plus b to the 5th takes the place of 3x plus 1 over y squared to the 5th. Now, to use the binomial theorem, we know ahead of time what the answer is going to look like. We're going to have a term with a to the 5th, 4th, all the way down. A squared and an a. And likewise, we'll have terms with b's. And the thing to remember here is with an exponent of 5, in each of the terms, the two exponents will add up to 5. So here there's a b to the 0, which is equal to 1, so I'm just going to leave that. I've got b to the 1. Notice 4 plus 1 is 5. B squared, b cubed, the 4th power of b, and now there's in fact one more term. That one more term would have a to the 0, which is just 1, and the 5th power of b. So simple enough to remember here, we have a to the 5, 4, 3, 2, 1, and b to the 1, 2, 3, 4, 5. And we line them up such that the exponents always add up to 5, and we'll put a, the first term, in descending order. Now we need the coefficients. That's the numbers that get multiplied by each of the terms. Those coefficients come from the 5th line of Pascal's triangle. That's the 0th line, that's the first, second, and you recognize the second line is the first one with a 2. And remember here with Pascal's triangle, you get each term by adding the two terms above together. So 3 plus 3 is 6, 3 plus 1 is 4, and so on. So this is the 5th row of Pascal's triangle, and as it turns out, that will also be the coefficient of each of these terms. So we've got 1 a to the 5 plus 5 of these, 10, 10, 5, and 1 of those. So the expansion of a plus b to the 5 is a to the 5, 5a to the 4, b to the 1, 10a to the 3, b squared, and so on. Now remember, our original question was 3x plus 1 over y squared raised to the exponent 5. A is taking the place of 3x, and b is taking the place of 1 over y squared. Here's where you have to be careful. We're going to substitute our values back in. Now, don't copy this. I just want to show you the wrong and right way of doing this. Let's say, for example, we've got the 5th power of a, and a is equal to 3x. It might be tempting to go like that. I've copied that where a was, I've raised it to the exponent 5. The problem here is this doesn't quite work. The reason why is that exponent, as it's written like this, only applies to x. This is not correct. The 5th power of a is a multiplied by itself, and you have 5 copies. If each of those is equal to 3x, what you really have is the 5th power of 3 times the 5th power of x. So to be clear, when we make the substitution, very carefully put brackets around the entire thing that's replacing a. That's going to give us the fifth power of 3 times the fifth power of x. Okay, so we're going to make that substitution here. I'm going to replace every a with 3x and every b with 1 over y squared, and I'm going to use brackets to make sure we get this right. That's not a 2, sorry, that's a 1. That's a 4. And finally, we've got 1 over y squared, it's a fifth power. Okay, so to do that substitution, every a has been removed and a 3x in brackets is put in its place. Every b has been removed and 1 over y squared in brackets is put in its place. Now we're going to apply our exponent rules. So here we need the fifth power of 3. So that's 243x to the 5. Here we need the fourth power of 3 and then multiplied by 5. That gives us 405. X is raised to the exponent 4. And we have 1 over y squared, so we're going to divide that whole thing by y squared. Over here we've got 10 times the third power of 3 times the second power of 1. So I've got the third power of 3, which is 27. Multiplied by 10 is going to give us 270. Now we have the third power of x. And we've got 1 over y squared, and we're squaring it. So let's review this exponent rule here. We've got 1 over y squared, and we're squaring it. Now, if we add a over b to the exponent n, we would raise both a and b to the exponent n. So that means we have 1 squared over y squared, which is being squared. Now we've got this problem here. If we have a to the exponent n and we're raising that to the exponent m, be slow and careful here. These two must be multiplied together, not added. So this is a to the n times m. Having two 2's here is a poor example because if you add 2's or multiply 2's, you get 4. Be slow and careful. Make sure you multiply them together. This becomes 1 over y, it's fourth power. So again, this exponent applies to the top and the bottom. And because the bottom already has an exponent, when we apply this exponent to the bottom, we multiply the exponents together. So that brings me here. We've got 1 over y squared becomes 1 over y to the 4. Now we've got 3 squared times 1 cubed times 10. 3 squared is 9 times 10 is 90. X squared. And we have y squared cubed, and y squared's on the bottom. We multiply. 2 times 3 is 6. So that's going to be y to the 6. You can start to see our emerging pattern. We've got y squared, 4th, 6. That's going to be an 8. And the x exponents just keep decreasing by 1. Now we've got 3 to the exponent 1 is 3, times 5 is 15. There's no exponent on x except, well, there's 1. We leave that unseen, so that's x. And we have the 4th power of 1 over y squared. Remember to multiply. That's going to be y's 8th power. And finally, 1 over y squared to the exponent 5 is going to be 1 over y to the 10, as 2 times 5 is 10. So 3x plus 1 over y squared to the exponent 5 is 243x to the 5, 405x to the 4 over y squared, 270x cubed over y to the 4th, 90x squared over the 6th power of y, 15x over y to the 8, and 1 over y to the 10. We made a substitution. We cleaned this up by pulling 3x and 1 over y squared out and putting a and b in their place, and then followed the binomial theorem, which tells us to write in all of these terms together such that the exponent here is in decreasing order from 5 to 1, and b's exponent's in increasing order from 1 to 5. The coefficients, that's the numbers multiplied by each of these, are drawn from Pascal's triangle. We then substitute back and carefully follow our exponent rules to end up with a simplified expansion of the original question.